850 rectangle area 2. We're given a list of axis aligned rectangles. Each rectangle sub I is just the corners, blah, blah, blah. Find the total area covered by all rectangles in a plane. Since the answer may be too large, return a modulo some number. Wow, that's tricky. Okay. So we have this example. We have just, what are the inputs? Just 10 to the 9, right? So I don't know why they, I guess maybe there's some language where there's no long, like JavaScript is weird with that, so that's why they make you mod. But let's see. For length 200, okay. Huh, okay. So I guess the tricky thing is kind of figure out the intersection and handling the intersection in a good way. Um, I think the canonical way of doing it is actually something called what is it called? Sweep line algorithm or whatever. Yeah, I think sweep line probably solves this. Was it 200? Uh, am I right? So basically, you have you can think of each rectangle as boxes. Uh, why am I that that sentence just didn't make sense. I just heard it myself. Sorry. But you could think of each rectangle as defense, uh, where and then each one you could maybe do you could do an O of n, and then yeah, and then that's probably sufficient. And I might do something. Yeah, I mean, with n equals 200, I could actually do something in linear per thing, so that is like n square ish. Because because if not, yeah, because I could do something n square ish. Because otherwise, I would do something with like segment trees or something like that to get it down to n log n, but it doesn't seem necessary. Maybe it's good practice, but I don't want to do it. Uh, but well, yeah, I mean, I think that they kind of have the requirement is so big that I mean, I know this one's is 49, but it's actually 10 to the 18th because it's was it a billion? Because it's a billion by a billion with right. And I think the tricky thing that they don't talk about, and I should have articulated this, so it's my bad. It's not is that you have 200 rectangles. You have like a lot of crazy intersections, and you have to figure out what the intersections are. And then when they intersect, maybe like two of them intersect, or three rectangles intersect, and then well, what happens there? Well, you have to make sure you don't double count or maybe even triple count, because if you just take like the sum of the areas, then you definitely double count or triple counting stuff, right? Because of the overlaps. So you try to figure out the area that is covered without overlaps, right? And I think so. Sorry, I need to explain this. I need to be better about explaining, but I just want to make sure that, or I'm just thinking it through in my head, where, but you basically have a straight line algorithm where you start with 0 and then you go to the next event and so forth. And each event is just um, the bounding box. So you could sweep either way, right? You could sweep from left to right, and then your events would just be like, okay, um, we start a box in from height x to a lower height x up lower. I don't know, right, and so forth. So I think that should be sufficient because given if you do n operation every time, there's only 200 rectangles, so uh, you're only doing 400 segments or whatever, something like that. So that should be sufficient. Okay, I think I'm gonna start coding, and then I could explain my code afterwards. I maybe my kind of explanation is a little wonky. Definitely feel free to ask more questions. I could kind of explain it the best I can. I just, sometimes I think it's a little bit because I don't have like an iPad or something to kind of draw some visualization. I've done it in the past, but it's a little messy. So and I don't think it helped anyone. So I'm gonna just write the code and then see if I could explain it that way a little bit more. Cool. Uh, okay. Okay. Now, what language do I want? Yeah, let's do Python. I feel like I keep on switching to Python. Didn't do anything in Python. Have I done anything in Python today? I actually don't remember. So okay. Um, hmm, okay. So what's an event? Uh, uh, I guess height, like what we were saying, height one, height two, and in or out, uh, which is what, toggle. I don't know. I need a better name for this, but hopefully you'll see. Maybe flag, type, something like that. Um, okay, what am I doing? Okay, so now for table and rectangles. Okay, now we also want an array. Right. Well, let's just do this for now. Naming is hard. Um, so now we want to create two events. So event of oh, huh, I forgot to insert the Y actually. So what is that? Bottom left. So this is bottom left. So that means Y2 is always higher than Y1. Okay. So so this is the Y, and it spans. And then the toggle is just it's the beginning of the event. So let's just say it's 1. And we also want to do the other event, which is 1, but now it's for the second Y, which is 3, hopefully, because otherwise it's a mess. And now we sort it. Yeah, should be okay. Do I need a lambda? Is this sufficient? We sort by Y. Yeah, it should be okay. We sort by height, so we start from the bottom. Okay, and now for, well, I guess this should be just your events. Haha, finally found how to name it. Oh, okay, let me just actually run it, just making sure I don't have a weird typo or compiling things. Okay. I mean, it's a good question now too. I mean, you're the Python expert, so you probably. I think I was thinking of another thing. I was thinking of pairs, but yeah, you're right. Uh, um, this is what happens when you mix languages, there. So like that. Oh, what am I thinking? Oh, key. I actually don't remember the syntax. Give me a second. Oh, key. Oh yeah, oh yeah, that's right, name tuples. You're right. You're definitely right now too. It's something that I've never used in the past. But this is what happens when you don't use a language for 3, 4 years production-wise. You just kind of forget. But what am I doing? Oh, let's do a two-string. Do I really need to print this? Fine. Just print the Y. No, you're definitely right. Name tuples. It's been a while. Oh man. Why? Something like that. Okay. That seems like it's right. Okay, well, I don't know if it's right, but it is maybe what we want. Okay. Now, okay. Now we keep track of area. Let's just say we return area. Oh, I went to do some mod stuff. Actually, I forget how long works in Python because I worry about that now. Like 64-bit int. So I'm just doing a quick. Yeah. And okay, well, we'll see what happens. Yeah. Is there a way to declare this as? Is it just like this? The one time I use Python, I had to do stuff that I forget. So anyway, so what happens here? Okay. So what happens during a sweep effect? Okay, I think we have to start with y. What is y? Okay, it should be in 0. So let's say we start with y. We start at 0, and then we have the set of stuff that's already in. So ongoing, say, name is. Excuse me. So now what happens? Okay. If event.y is not less y, then we go through ongoing to calculate to add to the area, right? Okay, then yeah, then, well, maybe not yet. For just want to make sure I get this right. But yeah, maybe this is also where I should use name tuples for the second part. But now just use regular tuples. I think that should be okay. Sorry, just think in my mind just in case. Yeah, I mean, I think it's kind of like what I'm going to end up doing is just kind of use because another way to do this is to another way to do this is to kind of keep track of it a little bit more. But maybe I'll just use 2 sweep lines to calculate this. That makes sense. And then okay. Yeah, I wanted to call it event again. That's why I'm struggling a bit. But okay, let's just call it this. And I should also practice using name tuples, but I'll do that offline. Used to use it a lot actually, but depth is and you see and then you add the area. Okay. Times the delta between last x and this event times minus last one. Are the signs right? Signs should be right. Okay. And that's x is equal to and in theory this should be good because they should all be closed parents. So I'm just thinking to see if my code is correct, but I mean I have to set this up so it's not by 4, right? But okay. Else well no I have to insert this event. Now you have an event. But now we just have an event that starts at here and ends at here. Okay. What if this? Ah, well, this is only if the event dot flag is. Wait, what? No, that's not. What am I doing? Well, this is just the processing part of it. But this we should always execute even. It's just that this if statement allows us to save some time because if we already is the same y, then all of these will be 0. So okay, so that's actually not a thing. Otherwise, you add a event. This is okay. If event dot flag is equal to 1, you add these. Otherwise, you actually have to remove stuff. Like you just remove add with an index or something. Well, not even. Okay. Something like that, except for we have to sort event. well, maybe not this, but well, we have to start ongoing. Uh, I guess this is where we. I think that to actually uh, uh, showed me how to do it last time, but so I'm going to try to do it with it. Insert. Um, is it bisect? Something like this. I will have to Google it, but something like that. Hmm. Is it bisect that bisect? Maybe. Yeah. I mean, if this is right on the first time, I'll be kind of actually surprisingly amused. But I didn't do the math, so this is actually wrong. But that's fine. That part is okay. Like we have easy solutions for that part. Um, Thanks, now too. Okay, well, is this sufficient? That weird edge cases. Like the first one is actually, I don't know. I wouldn't say it's the best, but it's pretty good. Maybe not stress test, but yeah, okay, YOLO. Maybe I'll just get something wrong. Oh, wow. That's actually kind of refreshingly surprising. Okay. Um, Also, thanks for your help, Noty. uh, what to say about this? So, I mean, trying to think about it a little bit. I mean, this is because sometimes it's almost kind of counterintuitively if you know the problem, like if you know the answer in terms of problems, then wait, what am I saying? If you already know the solution, then obviously it's I'm gonna. I guess what I'm trying to say is I think it's possible that I'm gonna have blind spots for this problem just because I solved this probably way too quickly. Uh, like if you know the answer, then obviously everything's easy, right? But I think sweep line is an algorithm that is a little bit underrated. I think for a lot of intersection E things, especially well, I mean, in this case, they tell you that it's axis aligned, which means if you think about like a sweep line, then like going from left to right, then you could draw a line. But actually, if you think about, but it doesn't always have to be like a straight line when you do sweep line. It's just like sweeping events and then kind of rounding them up in kind of some ways. Because I think the canonical example that people do for sweep line that is non straight line sweeping line is kind of the convex hull. If you, if, is it yeah, there are also like 80 billion convex hull algorithms, but think about convex hulls for some problems, like you could think about like you could have line sweepy things that are based on parabolas, like quadratic type equation type things. So it's something to think about. I think for me, not gonna lie, I think I'm gonna struggle a little bit to kind of just explain kind of uh, uh, how to kind of go through the pitfalls because I definitely do use sweep line, which is a thing that I think I've one. So this hasn't been true for a little bit, but when I was interviewing, definitely one of my go-to problems were using sweep line, and I would say that probably maybe 20% or less or fewer 20% or fewer people actually use this sweep line type ways to solve it. Usually they like I think the way that you maybe think about it another way is having a lot of if statements for these kind of problems. Like you want to do like segment intersection, so for example. You might have like a lot of if, you know, like you could visualize, a segment like this and like, oh, if x sub 1 is in between x sub 2 and y sub 2 or something like that, right? Where if you do a sweep line, then you just sort them and you don't have to worry about, I mean, and there is some trade-off with depending on what you're doing. Like maybe some stuff can be done in linear time, but because you're doing sweep line, then maybe it's n log n instead. But your complexity is so much, or your coding complexity is so much easier. So I think one thing that I would recommend just for this problem, to kind of look up and read up on sweep line or line sweep sometimes. Yeah, sweep line or line sweep algorithms or event type algorithms. And I think the key thing here is providing a structure that you could kind of go left to right. And actually, I should explain this problem instead of just generalizing a little bit. For me, what I did is that for how do I visualize this in a good way? But I sweep from left to right, and then from left to right, I kind of count up the subrectangles. So for this problem, from 0 to 1, at point at the vertical height 1, I would look at, well, like what are the segments I have, right? The segments I have are from 0 to 2. Well, from 0 to 2, and then you kind of get the area that way, and then you kind of get the rectangle between, from 0 to 1 2, and then and then the next one, well, you actually have segments from 1 0 to 2 3, and you kind of sum it up that way. And actually, I break that down even to like even minor chunks of, and this actually does more than what is required. But what the depth does is counts the number of intersections at those points. But because those rectangular or cellular intersections, you only count once instead of that number of times. You don't double count. That's kind of the algorithm I would do. And then and I also break down rectangle by two events, right, or event types. One is you add segments, which is what this part is for, and then the second part is for removing those segments. Actually, I could also probably do this removal with bisection too, right? Yeah, I guess I could have. But so I could even optimize that to, and in this case, actually everything is like really, no, it's still n squared as a result, because this is O of n, right? But yeah, so just to make it explicit, because I think that's what sometimes Python obfuscate this a little bit in terms of complexity, but because you have for each loop instead of for loops, or so that it's not always clear how far they go. But this is O of n because you can have n events all intersecting at the same time, and you have two n events, so it's O of n squared, right? Where space is well, and you saw it, but it gets dominated by this n squared anyway. And in terms of space, you only need you only ever have O of n things in ongoing, or 2n maybe, but O of n things in ongoing and O of n things in event. So your space complexity is linear. I think so. That's in terms of solving the problem. This is definitely a tricky problem, I would say, and there are a lot of edge cases if you do this another way. But I think this is something that I have up my sleeve that I do, and you could kind of see it, like, and you could kind of reason it a little bit, but you have to have some prior knowledge. But you could I mean, it's so. I think the thing about it is that it's really clean, right? So like you see me code it right the first time, and I make a lot of silly mistakes about by ones and so forth. So, and if I could do this correctly the first time without kind of thinking about it necessarily in depth, almost like unbelievably, then that's what I would recommend. So that's kind of me discussing the solution, because I think it's a little unique, or like the way I solve it is a little unique. In terms of interview, there are definitely a lot of these type of problems. So I'm thinking, So I think like if you happen to actually know how to do this technique, it's kind of good in the sense that like you always have there are a lot of similar ones like what's it called the water level problem or water drop level problem or something like that where you fill water to a building or like you have a skyline and you have to figure out like what's the area or something like that. So there are a lot of similar problems to this. So I think for better or for worse, it is something that, and as I talked about it before, I ask, um, I do ask line sweep algorithm problems, and I have, or I had in the past. Uh, Actually, it's easier than this one though, but yeah, I mean, definitely easier than this one, but still segment E problems that you could solve by line sweeping. So I would definitely recommend looking into it. But also, like I think that is within the expected difficulty of an interview problem. So maybe this one's slightly harder, but I don't think by that much, to be honest. So definitely something that I would consider as an interviewer. I think I've kind of there's a lot of overlaps, right? So in what I talked about, even though I guess that would be a good pun given the problem, uh, which is that. Yeah, I mean, I think this is relatively unexpected difficulty. So like maybe slightly harder, but still the algorithm is the same. And like I said, I did in 20 lines of code. So I would recommend that. Yes, I mean, I would definitely ask this or something similar. So so I wouldn't be that expected. But I think the only, and I think there is a good progression with this problem in the sense that if maybe anyway, let me walk through it. In that, like, if you're stuck, then you could do the naive solution. Well, what is the naive solution? Maybe, okay, well, if n is, say, 8, what can you do, right? Well, then you could do the, 2 to the n type thing to kind of calculate the intersection with inside out algorithm E, which comes in to play on different type of problems, but maybe not this one. Excuse me. Uh, but we could walk through like different ends to kind of simplify the problem a little bit and maybe give hints to because I think you could do this more kind of computationally. It's just that it's very tricky. So then we could kind of walk through that and kind of see what the edge case is. It's like, hey, and then what I would like to see is at least like the candidate is kind of thinking through, oh, this is wrong because X, Y, and Z, or well, this is right because but just not fast enough, etc. Uh, but yeah, overall, I mean, like I said, I might have a bias on this one, so don't take my word for it. But it is something that is very um, possible to be on an interview, possibly even on phone screen. So cool.